So in this video, we're going to do integrals where the cosine power is odd. So I'll give you an example what this looks like. This would be like the sine to the fourth of x cosine to the fifth x dx. And so what do we do when the cosine power is odd? Well, here we see that the sine power is even and the cosine power is odd. Remember the rule that we have done in the past is whenever sine is odd, well, sine is not odd here, so we have to come up with a new rule, right? So here the cosine is odd. And if the cosine is odd, what do? We strip off one cosine. Okay, so I'm going to pull off a cosine. So I have sine to the fourth x. If I pull off one of my cosines, I'm left with cosine to the fourth times cosine x. Remember, cosine to the fourth times cosine is cosine to the fifth dx right here. Okay, so I did those in different colors for a reason. You'll see in just a second. So, and make it your du after writing everything else in terms of sine. So do I have everything in terms of sine yet? No, this is in terms of sine, but this one is not. So how do I make this in terms of sine? When I think of even powers of sines and cosines, I'm thinking Pythagorean identity. So Pythagorean identity, sine squared x plus cosine squared x equals 1. And so if this is the case, if I solve for cosine squared x, I get 1 minus sine squared x, okay? And so I want it to be cosine to the fourth, not cosine squared. So how do I do this? I'm going to square the square. And when I square the square, that gets me cosine to the fourth x right there. And then to get this, I need to multiply out that nasty thing, okay? So let's do this. Let's substitute here. So this becomes the integral of sine to the fourth x, and then parentheses, substitute this with 1 minus sine squared x, and then times cosine x dx. Okay? So now I have an integral that is in terms of sine x, but my du is cosine x dx. So how am I going to get this into my u substitution that's helpful? Well, I'm going to say u equals sine x. Okay, that's going to get me this thing in terms of u instead of x. And then what am I going to do? Well, I take the differential, du is cosine x dx, which happens to be very nice because that substitutes quite nicely there. So this becomes u to the fourth times 1 minus, u squared. And then this whole thing here is squared. Sorry, I forgot that 2 there. And then this last piece right here, cosine x dx, is just my du. That's right there. Okay? So now I need to distribute this out. Distributing out might be the hardest part, maybe not, I don't know. Multiply this out, 1 minus u squared times 1 minus u squared. This is 1 minus 2u squared plus u to the fourth. So I have u to the fourth, 1 minus 2u squared plus u to the fourth du. Distribute the u to the fourth. I get u to the fourth minus 2u to the sixth plus u to the eighth. And let's see here. When I integrate, I'm going to get u to the fifth over 5 minus u to the seventh over 7 times that 2 there. And then u to the 9 over 9 plus c. But remember, our original problem was in terms of x. So I need to finish in terms of x. Well, u equals what? U is sine x. So everywhere I see u, I'm going to put a sine x. So that's sine to the 5th x over 5 minus 2/7 sine to the 7th x plus 1 over 9 sine to the 9x plus c. Okay? So I don't care if you write your fraction out front or if you put the whole thing divided by 5, whatever. I wrote it both ways so that you would hopefully feel comfortable putting it either way, whichever one floats your goat, so they say.